In last week's quiz, I asked you on a bonus question to tell me what's confusing about Java and what you've learned so far so that I can have a second chance to go over it with you and hopefully clear some things up. Now, the reason why I do this is twofold. First of all, when I've taught this class in person, uh, I always ask the same thing at the start of each class, what questions do you have from last week that I can help to clear up? And one time a student jokingly said, can you cover everything that you've covered so far this semester in 5 minutes? And so I took him up on that challenge and I did a 5-minute review of everything that we had covered that semester. While he was joking, I took it seriously. At the end of that semester, many students told me that was the most beneficial part of class, was doing that 5-minute, okay, let's just do everything from the start. Also, this was originally one part of a class that went over 3/4. So this was essentially a 1/4 class, which is 10 weeks. When UC went through semester conversions, semesters went to 15 weeks from 10. So instead of being a 3-class series, it became a 2-class series. Well, when it was a 3-class series, at the start of the second class, I would just ask everybody what was the most confusing thing that they didn't understand from the first 10 weeks, and then we'd go over it in one grand example. And so that's the reason why I want to do this here. So I want to go through everybody's suggestions, and there were quite a few good suggestions. I want to take a look at that, and then I want to do an example that is going to put all of these things together. So I categorized them, and these are word for word what you said. I categorized them into different subjects. So a lot of them are object-oriented concepts, extending classes and inheriting, saving data and using it in a subclass, how to avoid if tests with good object-oriented programming. That one, I don't want to say any one question is better than another because they're all good, and I didn't look at the authors for each of these, but that third bullet point, whoever submitted that, you get it. If you're asking that kind of question, you really have completely understood what object-oriented programming is all about. So let me go ahead and read that third bullet point. Since good object-oriented programming tries to avoid if tests, how do we avoid them for a decision? In other words, what are some ways to avoid if tests? So we'll take a look at that. Polymorphism, inherits versus implements. Okay, now this is a two-part question. For me, the hardest thing to do this class was the quizzes. They were confusing, especially the fill-in-the-blank questions. I want to stop there and say, I realize it's a little bit late in the semester, but if the quizzes are confusing, the best thing you can do is submit quiz question suggestions for two reasons. One is that's where a lot of the questions come from. So if you're suggesting questions, there's a good chance you're going to get the same question that you suggested, and then you already know the answer. And you're going to also get a list of everybody's suggestions, which essentially serves as an answer key to the quiz. Now, part two on this is that it's really about memory retention. In an online class, to be honest, it's easy to procrastinate, to take these videos and say, I'll watch them later, I'll watch them right before the quiz, something like that. But by having quiz question suggestions due on a Thursday, and then the quiz due the very next Thursday, it gives you a chance to commit things to memory right when you first see them, and then rehearse those things when you take the quiz again the next week. But also it kind of keeps you on schedule. It keeps you from procrastinating and putting off videos. So if you're struggling with the quizzes, my recommendation is to be rigorous on those quiz question suggestions. At the start of the semester, probably 80% of the students did quiz question suggestions. Right now, it's down to about 4 or 5 people, and to be honest, it's the same 4 or 5 people. So I haven't looked at grades, but I would bet you there's a correlation. I would bet you those who have filled out quiz question suggestions have done better on the quizzes for that reason. Okay, now part two, the hardest concept for me to understand was inheritance. So except for that quiz question, all of these essentially are talking about the same thing, so we will tackle that once as object-oriented concepts. Now we went down to knowing where to start when a program doesn't work like it should. This one was a one-off. Only one person asked this. That essentially is knowing how to use the debugger. And I did stress many times this semester that learning the debugger early is the best thing you can possibly do, both to save you time and also to help you understand what to do when a program goes wrong. So we'll take a look at the debugger. Next, several questions on constructors, constructing objects. Constructors confuse me more than anything. Constructors, I was often confused with sending data from one object to another. So all of these are related to constructors. We will take a look at that. Syntax and etc. Arrays and array lists, no problem. Try catch, okay. My problem is I have problems with understanding of the setup, such as syntax understanding, formatting, and the rules that make sense but put things in correct order mess me up. Okay, so some questions around the fundamentals, which I think we'll cover in context as we are going over what we're talking about here. I struggle with definitions sometimes. That can be difficult for me, and that makes the assignments hard for me to do because I don't necessarily understand what everything is doing. This last one, I would prefer some specifics on this. I don't know what definitions you mean. If you could throw a few words to me, that would definitely help me out. But as this is worded, I don't know how to answer the question. So let's take a look. We're going to start with a brand new NetBeans project, and I'm going to call it something like pets. So new project, and I'm going to call this one pets. And I honestly have not rehearsed this question. Oops, sorry. I have not rehearsed this. I'm just doing this based on the questions that you have asked me. So new Java application, pets, and finish. Okay. So if we take a look, it creates a main class, and we know that a main class is a class with a main method, and a main method is a starting point for a class. Now, by the way, there are a couple of things that I'll go through here that maybe weren't mentioned, but I will go ahead and state. Things I noticed when I was grading the projects. One thing I noticed is some people would throw everything in the main method. I strongly recommend not doing that. The main method should only start your program. You really don't want more than 1 or 2 lines in the main method. So we know the next thing we're going to want to do is make a method, public static void prompt user, open curly, close curly, and then from main, I'm simply going to call prompt user. Okay. And prompt user, remember we made that shortcut for JOption pane show input dialog, and I'm going to say enter your pet's name. Okay, something like so. And JOption pane, we're going to need to import that, so I simply put my cursor over it, hold Alt Enter, and that imports it. Now, we know that a JOption pane show input dialog is going to return a string, so we can create a string manually, or the other option that we can do is we can say, okay, introduce, this is a little tricky to get to, but introduce variable. It's a little easier to do by shortcut. If you take a look there, you see Alt-Shift-V. Now look at what that does. As soon as I hit enter, I'm going to call this one pet's name, pet's name, like so. And take a look at what it does. It takes what was gathered from the user and stores that into a variable called pet's name. And then we could do a system out print line, something like that, and we could display what the pet's name is. Now, debugger. Let's cover this one first because I think this one is the most important. I snap a breakpoint on line 21. I'm going to right click and I'm going to say debug file. Okay, give it just a moment. Okay, and we see the line turns to a mint green line. And now what I can do is I can press F7. Now this one we have to be very delicate because we're on a method call, so F7 means step into that method call. F8 means execute the method without actually looking inside. So the question is, do you want to open the door or do you want to leave the door closed? F7 says open the door. F8 says leave the door closed. Just walk by it. We know what's going on in there. Now I'm on line 25. You see that's mint green. So if I press F7 or F8 now, it's going to take effect on line 25. I press F8 and I should get a prompt. Sometimes it hides. And sure enough, here it is. Enter your pet's name. I'll just say checkers. And okay. And the program is now done. Okay, so this is a one-file Java program, which isn't very exciting. What we need to do is we need to add some more classes. So I'm going to say new Java class. And for this one, I'm going to say pet. No, I think we already have pets. Let's call this one animal. Okay, animal. Finish. Okay, now we have this class called animal. And what I'm going to do is I'm going to say public string make sound. Okay. And I'm just going to return default sound. Okay. And I'm going to save. Now we have two classes, and this is where the program starts to get a bit more difficult because we have to deal with this concept of sending data back and forth. As a matter of fact, what we can do, I'll tell you what, we'll keep it as it is right now. No, I know what we'll do. Well, yeah, we'll keep it as it is right now. I'm going to save, and I'm going to go to pets, and let's construct an object for our pet. So I'm going to say animal equals new animal. Okay. And then I'm going to say JOption pane, show message dialog. Okay. Null. So this will show essentially a message box to the user. And then I'm going to say pet's name plus, and then a space, and the word says, and then a space and a double quote, plus animal dot make sound. Okay, let's see what happens this time. I'm not going to debug it. I'll go ahead and just run the file. Enter your pet's name, Checkers. Checkers says default sound. Well, obviously, this isn't very helpful, is it? Checkers says default sound. Checkers is a dog, right? Well, you didn't know that, but I do. Checkers is a dog. Now, a dog makes a different sound than a cat, right? So what I'm going to do is I'm going to subclass animal, and I'm going to make a new class called dog. Okay. And I'm going to say public class dog extends animal. Okay. And I'm going to override that method make sound. Now here's an interesting thing. Notice I can start typing the method I want to override. I can hit Control and space, and it will take a guess and say, you know what? I think you want to override this method make sound. If you do, hit enter. I hit enter, and take a look. It is almost that exact same method we had up above. Public string make sound, public string make sound. Here, I'm going to return woof, because that's what Checker says. Save. I run my program again, and now I want to show you a subtle difference. I'm not going to make any changes just yet. Enter pet's name, Checkers. Checker says default sound. You see, nothing has changed yet. Even though I made this new class called dog, nothing has changed yet. Okay, but now watch something. Okay, look at my construction here. Do you see animal equals new animal? Okay, in this case, the variable type and the object type are the same. But watch what happens when I simply change this from animal to dog. And let's watch again. Run. Enter your pet's name, Checkers. Checkers says woof. Now, do you see that difference? Do you see that by changing the object type from animal to dog, instead of getting default sound, we're now getting woof. Okay, so that's polymorphism. Polymorphism, the variable type, which is this here, tells us what methods we're allowed to call. The object type tells us what's actually going to happen. So you notice animal.makeSound, okay? You notice that we're calling that makeSound method, which is defined on class animal, but we're actually getting the behavior out of dog. Very interesting. Let me say a little bit more. So let's make another method, but this time we're only going to do it in the class called dog. I'm going to say public void chase squirrels. One thing Checkers really likes to do. Okay, and I'm just going to leave this as is. I'm going to save. And now we go back to pets. Now in pets, let me take this make sound and move it out of this JOption pane just for a moment and do just a bit of tidying up here. There we go. You see how everything's good here. Everything compiles, no problem. Now remember that method I made called chase squirrels. What happens if I try to call animal.chase squirrels? It's going to give me a compile error. And the reason is the variable type is animal. Remember with polymorphism, variable type tells us what methods we're allowed to call. There is no chase squirrels method on animal, which is why we now get a compile error. Now, if I changed this to dog, the compile error will go away. because that method is available on dog. But the problem is now I couldn't store a cat into animal because, well, first of all, I haven't made class cat yet, but secondly, a cat is not a dog. So we need to change this back to animal. Honestly, I'm just gonna Control Z to put this back how it used to be, just like so. There we go. Okay, so there we go, and I'll save. Now, we had a question about how to pass data from one class to another. So one thing that's very important, we have to have something like this. We have to construct an object before we can pass data from one object to another. Now, first of all, we need somewhere we can receive the data. So let's go back to animal, and let's say private string name, and then Alt-Enter, or that's not going to work for us. So right-click, refactor, and I'm going to say encapsulate fields. That'll give us a getter and setter method. Yeah, that's fine, and refactor. So now we have a variable, or more specifically, an attribute or an instance field. They tend to go by different names. We have a variable at the class level for animal. You know what? I'm going to make that protected, actually, because protected, well, a lot of people don't recommend using protected. Protected means that our subclass called dog has direct access to this variable as well. So let me go ahead and make it protected, but nonetheless, you see get name and set name. So what I'm going to do now is in the make sound, I'm going to say name and then plus and then default sound. So we'll say name plus says plus default sound. So that would say checker says default sound essentially. I'll do the same thing down in dog. Where we have make sound, I'm going to change that to checkers says wolf. Okay, just like so. And save. Okay, now the question is, how do I get checkers name from pets over to dog? Well, that's easy to do. All I need to do is say animal.setName, and then we'll pass in the pet's name that we collected up above. This is where the debugger is really handy, to be honest with you. So I choose save, and now I'm going to right click on pets and I'm going to say debug. We see the prompt user is green. I choose F7, which means open the door. What's inside, and then F8. F8 means execute the line. The next line to execute, where I just hit F8, was 25. And you see we now have a prompt that says enter pet's name. So I say checkers and OK. Now I mouse over pet's name, and you see that we can get a view right here and see that pet's name is checkers. Now we're constructing a new animal, and I call animal.setName pet's name. Watch very carefully as I choose F7 and look at what happened. If you look up at the top, we're now in the tab called animal. We now have the name checkers, and we're storing this into this animal. Okay, F8, F8, and now we're back to pets again. And now we have just collected data from prompt user, and we have stored that data into a different class. Now, well, I'm going to choose F8, and we're going to see checkers says wolf. Okay, so a couple things I need to do here to clean things up. We no longer need all of this stuff here because that gave us checkers says twice. I save, I go back to dog, and I'm going to just kind of add a few spaces there and save, and we'll run this just one more time. Okay, enter your pet's name, checkers says wolf. So you see that what we did is we passed the name checkers from pets to animal, or more specifically from pets to dog, because dog extends animal and dog is the object that we are creating. Okay, good. So what's next? Next thing, constructor. We passed the pet's name through the constructor. Now here's an interesting thing about constructors. We get this default constructor, we don't have to do anything. If I say public animal, like so, okay, now animal has a default constructor. That's actually created for us if we don't type it out like so. I'll do the same thing in dog, public dog. Okay, so that's what's considered the default constructor. That, oops, public, I missed an L there. That's what's considered the default constructor. That's given to us automatically, and that's what physically is getting called here on line 28. But we can make another constructor too. I could say public dog and then string name. So this is an overloaded constructor because it has a different parameter list. And I could say then set name name, like so. From dog, I can call set name name, just like so. I can do the same thing in animal. I could say public animal, okay, string name. And here, whoops. And here once again, I can do this one of two ways. I can say set name name, or I could say this dot name equals name. So I can either change the name of the animal by calling the setter method right down here, or I can directly change the variable name. Either way will work. It will do the same thing. Now let's go back to pets, and you see what I can do. Instead of calling that setter method, is I can simply pass in the pet name like so, and save, fingers crossed. And what does it not like here? Pet's name's okay, misspelled the variable, so it should be pet's name, as in pet possessive. There we go, and save. This will work the exact same way. I won't bother debugging this. Actually, I will. I will debug this. Let's watch this closely. F7, I want to open the door. F8, I want to execute over this line. Just a moment, I'm going to run over, grab the pop-up box, and we'll say checkers. Okay. Now watch carefully. Watch the tabs here. We have pets lit up right now. I choose F7 and look at where we go. We go to this constructor that I just made on dog. Now watch again very carefully. You see we're in the dog class now. Watch when I choose F7 where we go. We go to the animal class because dog is inheriting that method set name that we're calling in the constructor here. Okay, so F8, 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 we'll go all the way back, and sure enough, there we go. Checker says woof. Okay, so that's constructors. That's passing data from one class to another. And we've also taken a look at inheritance. We had another question, which was avoiding an if test. So what I can do here is I can say, just to save us a bit of time, I have typed out a couple of lines in advance, and this is going to ask us if we have a dog or a cat. Okay? So string animal type equals dog or cat, and I save. Okay, so now what we're going to do is we're going to say if selected animal dot toString dot equals double quote dog, close double quote, then animal equals new dog. Okay, and then I'll say else if, and I'll make a kind of similar test. Okay, selected animal equals cat. Then we're going to say animal equals new cat. Now I'm a little bit sloppy. Alt-Shift-F, that will align our tabs quite nicely. And you see now it's mad at me because I have nothing called cat. So let's make a cat. So I'm going to say new Java class, and we're going to call this one cat, and finish. And we're going to say cat extends animal. So we get all that good stuff we already got with animal. We're going to get that with cat now as well. Okay, and then we're going to say public string make sound. Actually, I'm sorry, I'm doing it the long way. Let's do make and then control space, make sound, override the method. Okay, and for this one, we're going to say return, and we're going to say get name plus space says plus meow. Okay, and save. Okay, back to pets. Now, I haven't set up a constructor for this cat, so we could set up a constructor, but I'm just going to go ahead and say animal.setName and pet's name. That'll work just fine. Okay, now one other thing I want to do. You see I've declared two variables called animal. That's not very efficient, and those variables are going to go out of scope quickly. So I'm going to do a little refactoring. I'm going to declare the variable in a different place from where I am instantiating the variable, or in other words, putting something in the variable. Animal equals new dog. And like so, animal equals new cat. So I'm going to make this very clear here. Declare variable, okay? Construct a dog, and in this case, we're going to say construct a cat. Okay, and save. And with any luck, okay, I need to do one other thing. I just need to initialize this to null. There we go. Save, and now let's run. And this time we're going to say Bowie. And we're going to say Bowie is a cat. Bowie says meow. Okay, one more time. We go through it again. Run. Make sure that checkers still works. Checkers. Checkers is a dog. Checkers says woof. There we go. Okay, so what's interesting here is that one of the questions we had is, how do you use polymorphism? How do you use inheritance to get rid of if tests? We see we do have an if test right here, okay? But the decision on whether to say woof or meow lives in the class dog or cat. And if we added other things, if we added a snake, a mouse, a hamster, a fish, whatever, the decision on what that animal says is in the class that represents that animal. If you remember my classes versus objects lecture, a class is essentially a noun. Okay, we still have this if test, and there's a little bit of magic that we can use to clean up this if test. Now, I don't want to explain this step for step just because I know this video is going to go very long. So I don't want to make it any longer. If you're curious on what's going on here, I'll be happy to point you to a video that describes what's going on. But I'm going to use something called reflection and say class.forName. And what happens here is this is a different way to construct an object. We essentially pass a class name as a string, and it constructs an object of that type. But when we pass the class name, we have to pass the package name and the class name together, which is why I'm doing a little concatenation here. Pets plus selected animal. Okay, class.forName, I'm sorry, .new instance is what we want. Okay, animal equals class.forName. Okay, new instance. Now we're getting a red line here, and this is a class not found exception. Okay, so one of the questions that we had was, what is a try-catch block? This is a checked exception because what we're looking for is a class in package pets. If you take a look over here, there's package pets with the name either dog, capitalization and spelling is the same, cat, capitalization and spelling are the same once again. If I happen to misspell something or I put in the word snake or mouse or whatever, it wouldn't know what to do. And it would throw a class not found exception. So what I need to do here is Alt-Enter and say surround statement with try-catch block. And what it's going to do is it's going to take the risky behavior here. And if it cannot figure out what to do, if it doesn't know what a snake is, it doesn't know what a mouse is, it comes down here to the catch block. And the catch block says, oh, okay, I'm here to handle the error scenario. What's very important, though, is anything that is in the try block after this checked exception can be thrown, anything in this area I'm highlighting now will execute only if no error is thrown. So use this to our advantage. Let's take everything that depends on the animal being instantiated properly. Let's put that in this try-catch block. Now, take a look. You see it looks really sloppy right now, and that's why I was very strict this semester on programs not looking sloppy, because first of all, look at it. You can barely read what I'm doing here. Everything is misaligned. A quick Alt-Shift-F will fix this. I'm sorry, yeah, Alt-Shift-F. Everything's aligned nicely. You see what's going on. Okay, and I'm going to take this J option pane one moment. We're going to put that. Okay, so just to reemphasize here, this is a risky behavior which might throw an exception. If an exception happens, it skips everything I'm highlighting here and comes to the catch block and executes that. If no exception happens, it will execute everything I'm highlighting here, but not the catch block. So use that to your advantage. Put stuff that's dependent on no exception happening right here between the try and the catch. Okay, we have one more thing. If I mouse over, we are going to need to cast this to an object of type animal. Okay, now you see we're in good shape. And the other thing, because I'm doing this reflection creates an object by its string name. You see, because I'm using reflection, I can now remove this entire if test. And my program gets incredibly cleaner. There is not a single if test anywhere in my program now. Not a single if test. I go ahead and save. Okay, what do we not like here? Okay, I'm gonna do just a bit of refactoring. There we go, and save. Okay, you see a very small program, very efficient right now. As a matter of fact, I could clean it up even more. I could say animal, animal, like so. Animal, animal equals class 4 name. Very nice, very clean. Okay, not a single if test, but still the decision on whether to say meow is in cat or to say woof is in dog. So I go back to pets, okay, and let's try this one more time. I'm going to go ahead and run the program. Enter your pet's name, Checkers. Checkers is a dog. Dog says woof. Okay, run one more time. Okay, enter your pet's name. For the pet's name, we're going to say Bowie. Okay, Bowie is a cat. Bowie says meow because a cat is meow. Now, let's look at what happens if we extend this. And let's go ahead and come up with another animal. Let's say that we have a, I don't know, I want to say we have a pet snake. And I guess a snake hisses. I don't know. I've never had a pet snake. I simply add the word snake here. And now I go to pets. I say new class. I'm going to say snake and finish. And I'm going to say make. Override that again. Nope, not what I want. No, not that. Oh, I know what I'm missing. Public class snake extends animal. There we go. Okay, and I made this line by mistake. Let me go ahead and remove that. There we go. Now I'm going to try one more. Let's override make sound. And for this one, we're going to say pretty much the same what we've said before. Get name. And then we're just going to say plus, and then says hiss. I don't know what else to call that. I would think a snake says hiss. So we'll leave it at that. Now notice I made very minimal changes to this class called pets. All I did was add another option for the user to choose. And again, no if test. I can't stress enough, no if test. Let's go ahead and run. Enter your pet's name. We still have Checkers the dog. Okay. Checkers says woof. Okay, run again. And we still have Bowie the cat. Okay, Bowie is a cat. Okay, Bowie says meow. Okay, and then let's say run again. And this time we're going to say Sedgwick. Okay, Sedgwick is a snake. Sedgwick says hiss. So you see the subclass knows what to do in each of these scenarios. So passing data, creating objects, constructors, polymorphism, inheritance, debugger, we've covered quite a bit. Let's see what else we need to cover. Okay, so we got object-oriented concepts, we got debugging, we got constructors. I think we've knocked out each of these. Try-catch, arrays and array list. I think that's it. Okay, so let's go ahead and do arrays and array list. So you see, every time I've run this program, I've had to start it over. I'd rather not have to do that. So what I can do is put in a collection. I might have more than one pet. So I'll say array list animal. Okay, all pets equals new array list animal. Now note what goes in that greater than less than symbol has to be a class type. Okay, I'll do a bit of importing here. Alt enter, add import. What goes in that less than greater than is a class type. I don't want to do cat because I can only have cats as pets. I don't want to do snake because I could only have snakes as pets. I don't want to do dog because I could only have dogs as pets. Although for me, frankly, that's quite fine because I love dogs. But I want to do animal so that I can have any one of these as a pet. So you notice I make it the more general superclass type. Now what we're going to do is we're going to put in a do while loop, do while, and then we're going to say more pets. Well, hang on just a second. We'll say J option pane show confirm dialog. I was hoping for a bit of, I see, hang on, show confirm dialog. And let's see, parent component message, title, option type, that'll work well. Okay, so null, message, do you want to, oops, I need to do that as a string, don't I? Do you want to enter another pet? Okay, title, another pet. Okay, and then finally, the last one is going to be JOption pane. We want to say that we want a yes, no button. So I'm going to say yes, no option, just like so. So that's going to give us a JOption pane with the yes or the no option. Now, let's go ahead and save this into a variable. Remember our trick for that, refactor, introduce variable. It takes whatever this method returns and it saves it into a variable. We'll call that variable another pet. Okay, so int another pet, that's going to hold our decision. Here I'm going to say while another pet equal JOption pane dot yes. Yes option, which means the user chose yes. Okay. One trick though, I need to take this declaration and put it into scope. Through a very funny twist of logic, we have to declare it above the do to make it in scope. I also have to take away the final to mean that it can be changed later. Also, you see, once again, I have a lot of nesting going on here. It's starting to look pretty ugly. So what I'm going to do is do my Alt-Shift-F, which is going to fix my tabs, make it much more readable. So now we're looping. Now we're saying, do you have another pet? Do you have another pet? Do you have another pet? Before we do that loop, let's take the current animal that we've created and add it to this array list of all pets. Allpets.add, and we'll say animal, like so. Okay, now what we can do is let's take this message dialog and let's remove it from this prompt loop. So I'm going to highlight, Control X, and now what I'll do is a for each loop. I'll say iterate, whoops, iterate over all pets, print out their greetings. Okay, greetings, sorry, I'm a little picky on that. For each, F-O-R-E, Alt Enter, whoops. Didn't give me what I want. Whoops, sorry. Okay. I simply had the wrong keys going. So for each, Control Space, and it's going to make a for each loop. Notice that NetBeans is smart enough to figure out a for each loop is typically iterating over something. And it figured out the something that it wants to iterate over is our collection of animals. So what we're going to do now is Control V, and we're simply going to print out animal make sound for each animal. The only thing is that word animal, we have to make that like so. We have to make it one and the same like so. Although, yeah, that'll work. Okay. Now, what doesn't it like here? All pets add animal. Did I misspell? Cannot find symbol. Okay, I see. Actually, I'm sorry. I need to move this guy up because it's trying to access a variable that's out of scope. Now it looks a whole lot better. So we have a do while loop. Within the loop, we're creating animals. We're adding those animals to a collection. After the do while loop is finished, we iterate over that collection and we print each animal one at a time. So that's the advantage of array lists. Let me go ahead and choose run, and your pet's name Checkers. Okay, Checkers is dog. Do you want to enter another pet? Yes. Ooh, looks like we missed something. No. Okay. Now you see that gave me not the expected result. It kept prompting over and over again. Looking through the debugger, I could pick that out very quickly. What it is I simply need to take these prompts that I've declared up above, and I need to move them into this do while loop. That's okay, that's what the debugger's for. I'm not perfect, nobody's perfect. And the debugger will help us figure out, okay, when something goes wrong, what's the fix? I paused the video for a second to run it through the debugger, and that's what I found out. I found out that it was just a matter of I had things outside of the loop I thought were in the loop. It looks like I'm not completely perfect just yet. I need to take this collection. Because the collection is used by both loops, I need to put it outside of both loops so it is accessible within both loops. By accessible, I'm talking about variable scope. Remember, a variable is alive from the point where it is declared, and declaring means a name and a type. A variable is alive from the point where it is declared until the closing curly of the block where it is declared. Okay, so that's what's going on here. Just a moment. Looks like, okay, let me let that, I think I had a previous run that was still going. So we'll go ahead and save. Okay, so at this, I think I accidentally hit the debugger there. At this point, we're finally in good shape. So just a moment. Okay, let me kill one more option here. There we go. So now we're finally in good shape. We have the collection up above, okay? We have our variables, and we have to be careful here because we have a lot of curlies, so we have a lot of things that might go in and out of scope. But in any case, let's go ahead and give this a final run. Okay, pet's name Checkers, and Checkers is a dog. Do you want to enter another pet? Yes. And okay, you see, this is better. Before it just kept saying, do you want to enter another pet? Now it's reprompting me. Bowie? Bowie is a cat. Okay. Do you want to enter another pet? Yes. We're going to say Sedgwick. Okay. Sedgwick is a snake. Do you want to enter another pet? Yes. Bugsy. Bugsy's a dog. One more pet, Kaz. Oh, let's do one more. We're going to do the history of my dogs. Merino. Don't want to leave out Merino. Merino is a dog. Do you want to enter another pet? No. So at this point, I have an array list with 4 dogs, 1 cat, 1 snake. And we're now at the point where at this line number 47, we're about to finish up the first loop and go to the second loop. The second loop is going to show us 1 message dialog for each animal I have. So I choose yes. Okay. Oops, I didn't mean to choose yes. Oops. Okay, we'll say Balo. I meant to choose no. We'll say Balo. We'll say Balo's a cat. Okay, do you want to enter another pet? Now I'm going to say no. Now, Checker says woof. Bowie says meow. Sedgwick says hiss. Bugsy says woof. Kaz says woof. Marina says woof. Balo says meow. So that part you just saw was this loop where it was iterating over the collection. And once again, the decision of what to say was left up to the subclass that represents the animal. Notice not a single one of them said default sound. It was either meow, or it was woof, or it was hiss. None of them went with the default. However, what you'll also notice is that from pets, we called set name, right? And where does set name go? Set name does go to the superclass called animal that has default sound. There's not a set name method in snake. There's not a set name method in dog. There's not a set name method in animal. I'm sorry, in cat. There is a set name method in animal. But because each of these inherits from animal, if they don't have the method called set name or get name, they will inherit that from animal. So I know that was quite a bit to talk about, and that was a little fast in going through it, even though we ended up at about 45 minutes on this video. But nonetheless, that one example goes through and answers every one of the questions that you submitted. So I hope that was helpful. If you have any more, certainly add them to the end of this video in the comments section, and I'll be happy to put a little response of how I would answer your question. Thank you.